This video finishes lesson 1.1, sets of numbers. Looking at interval notation, whenever there are parentheses, that means the endpoint is not included. When you see brackets, that means the endpoint is included, and vice versa. The first bullet point here, positive or negative infinity, means unbounded in either direction, positive or negative, left or right, and it's used with parentheses. Secondly, the word or means union. A set includes more than one interval. So ages between 12 and 14 or between 16 and 17. In the first example, before getting there actually, look at this box in blue. This is the Rosetta Stone of interval notation. Commit it to memory. The first row correlates greater than and less than with just a open dot. So we'll call that a circle, meaning it's not included. That's why it goes with the positive and negative infinity as well as the parentheses. All those go together. In the second row, we have the greater than or equal to and the less than or equal to. Because of the partial equality, the or equal to, it's a closed circle or filled in. So we'll call that a dot, and that you can see here. That goes with brackets. Notice it does not go with anything involving infinity. That's because infinity is not a number. How could you include it? Moving to the first example, we're given this compound and inequality. So it's a conjunction. X is greater than 7 and x is less than or equal to 12. It's all about the x. The way to write this in interval notation is first to realize that we have a strict less than inequality. Notice that the 7 comes first. Now, is it included as a possible value for x or not? It is not, so we use a parenthesis. Then we use a comma to set up an interval, and it goes to 12 included because it's x less than or equal to 12. And that is it for interval notation, and we don't use the variable. It's implied. For the next example, we're presented the information using a number line. So to go from this visual to interval notation, we first should mark our number line. The left is to negative infinity. So that's the first thing that we see. If you recall in the first example, we worked left to right to create our interval notation. In this second example, doing the same thing, I first write negative infinity. I know it's not a number, but it's a concept, and the negative represents to the left, and it's not included, so I pair it with a parenthesis. And it must be parenthesis, then the negative infinity, not the other way around. Well, we set up the interval using the comma, and it goes to and includes -2, so we use a bracket. And now there's a break in the graph, so we use the union symbol. So that goes with the or from above. And the updated note sheet clarifies that better. Don't use the word or. That will be used down below for set builder notation. So we use the symbol for union. And then we pick up with this other part of the interval. Included is -1, and it runs to -1/3, not included. And that is the interval notation represented there in the number line as well. Here we have two sets of inequalities. The first one is a conjunction. The second one is x greater than or equal to 5. For the first inequality, negative or just 1/2 is included because x is greater than or equal to. So we use a bracket, 1/2. Then we run the interval to 3, not including it. The word or means union. Now, be very careful here. This is x greater than or equal to 5. Visualize that. So it actually starts and includes at 5 and then goes towards positive infinity. That's very hard to wrap your head around. So it may help you to make a number line of the inequality first, so then you have the visual, because I think this interval notation represents the visual very well. So if you find that's the case for you, I encourage you to make your number line first. So notice I'm going to put a dot at 5 and then it runs to the right. So that's why with the right tail of the number line, that's positive infinity. And now it might be easier to see where the interval notation comes from. Moving on to set builder notation. This uses properties of the elements of the sets of real numbers to help further clarify what you're talking about. So you start off with a bracket, the variable of interest, it could be a y. This vertical line segment is read as such that you give the inequality, or the list, whatever it may be. You also have the power to finish by saying the subset of reals to which these numbers belong. Without this last statement, you might assume that this is the set of all real numbers between 14 and 19 inclusive. That's not the case. We only want the rational numbers using Blackboard Bold. Looking at the first example, think about what subset of numbers this is. The integers. So I'm going to set up a curly brace. I'm going to choose lowercase I for my variable. Your choice could be n, could be x, such that, you got to follow the notation, such that, so I is defined such that -3, let me pronounce this correctly, I is greater than or equal to -3 and less than or equal to 2, and I is an element of the set of integers. So the symbol there that looks like an E means element of. For the next example, we have the real number line. Because it's the set of reals and not a subset like in the previous example, integers, we won't have to include this last piece. So instead, our answer is the following. We say, starting with the brace, I'll choose n this time, such that, so it's defined as, well, this is -infinity, but you write the number first, or sorry, the variable first, so it's going to be n is less than or equal to 3, or, don't use the union symbol, this is set builder notation, you use the words, or n is greater than or equal to 4, and strictly less than 8. Because it's the set of reals, I don't need to include the and n is an element of the set of reals. It's implied, kind of like you don't write 1 in front of x, it's implied that it is just one copy of x. For the last example, whole numbers less than 5. Okay, I'll use x this time. So it's the set of whole numbers x such that x is greater than or equal to 0 and less than or equal to 5. And because it's a subset of the reals, I must specify that x is an element of the set of whole numbers.